I'm Chris Field. I'm the director of the Stanford Woods Institute for the Environment and a climate scientist who has worked on climate change impacts, adaptation, and vulnerability for more than 30 years. And today I'm pleased to share some thoughts with you on why it's not too late for action on climate change. Of course, it is very late, and it is way too late for more delay. The real thesis of my presentation is that we've already put ourselves in a position where there are harsh and unavoidable changes in climate baked into the system, but where the opportunities for avoiding the worst impacts are still live and actionable. Let's start with a little background. The warming recently has been totally dramatic. 2024 was the hottest year on record. It was the hottest year by quite a large amount. It was warmer than 2023 by about almost 0.2 of a Celsius degree. 2023 was warmer than the previous warmest year by approximately 0.2 of a Celsius degree. And 2024 was warmer than the 20th century average by about 1.3 degrees Celsius, and it was strikingly the first year in the instrumental record that was warmer than 1.5 Celsius above pre-industrial temperatures, the aspirational goal of the Paris Agreement, and an indication that we're headed into very dangerous terrain with climate change. We're also in an environment where emissions continue to increase. Emissions of carbon dioxide in 2024 are estimated at 37.5 billion tons of carbon dioxide, up approximately 1% from the year before, and frustratingly still climbing over the past 35 years, shown in this image. And this period from 1990 to 2024 is significant because this is a time during the entire sweep of which we have been aware of the potential for serious impacts of climate change. We've talked about addressing it, and even though I'll argue we've made some progress, we haven't made enough progress to have emissions start to come down. And of course, when we talk about climate solutions, we need to talk about emissions, especially of carbon dioxide, going all the way to zero. Leveling isn't enough. Decreasing isn't enough. These emissions need to go to zero. We also are in an era where the impacts of the changing climate are stark, whether we see it in heat waves, wildfires, floods, the kind of devastating events that we saw in Los Angeles earlier this year or in Texas over just the last few weeks, really underscore and put a giant exclamation point around the fact that we are seeing profound impacts of climate change. It's costing lives, and it's costing billions of dollars. If you look around the U.S. in 2024, we had over 27 disasters, each of which cost $1 billion or more to address. That was the second highest number of billion-dollar disasters ever. The highest number was 2023, when there were $28 billion disasters. There are, however, 3 pieces of good news that I want to start out with. The first is that the causes of climate change are well understood, and as a result of that, we have a solid basis for action. The second is that the consequences of further emissions are reasonably well constrained, and we can, with a high level of confidence, talk about the impacts we expect and the extra impacts we cause with further emissions. And the third piece of good news I want to start out with is that the solutions are mostly available, they're affordable, they're safe, and they're reliable. Let me go into just a little more detail about each of these 3 pieces of good news. This is the cover sheet of a scientific paper published in 1896, 129 years ago, by the Swedish chemist Svante Arrhenius, and he talked about the consequences of burning coal for climate. In 1896, 129 years ago, Arrhenius knew the three fundamental things that you need to know in order to understand the sensitivity of climate to carbon dioxide. He understood that carbon dioxide is a heat-trapping gas, and more of it in the atmosphere leads the atmosphere to be warmer. Arrhenius also understood that a warmer atmosphere holds more water vapor, and the water vapor is also a heat-trapping gas, and because the warmer atmosphere holds more water vapor and the water vapor traps more moisture and more heat, you end up with this amplification of the CO2 signal. The third thing that Arrhenius understood is that in the long term, any carbon dioxide that's emitted to the atmosphere is partitioned between the atmosphere and the oceans, with the CO2 that dissolves in the oceans, making them more acidic, but also resulting in only a fraction of the carbon dioxide staying in the atmosphere. Knowing these three things, you can calculate the consequences of doubling the concentration of carbon dioxide. Arrhenius did that. He didn't get exactly the answer we get today, but he got close enough to demonstrate that those three pieces of information, well understood in 1896, not challenged since then, really are the scientific basis of the relationship between greenhouse gases and climate change, and have been actionable for many, many decades. We know everything we need to know that carbon dioxide has caused and is causing climate change, and that the solution is to decrease emissions of carbon dioxide and bring them to zero. We also have relatively good constraints on what will happen with future emissions. The reason we understand this is that there is essentially a straight line relationship between the total amount of carbon dioxide released since the beginning of the Industrial Revolution, more than 100 years ago, and the total amount of warming. To date, we have released something over 2,500 billion tons of carbon dioxide to the atmosphere, resulting in a warming of just about 1.5 Celsius. If we wanted to limit warming to an average of 1.5 Celsius, we would have a total cumulative budget slightly above what's been emitted so far, approximately 2,790 billion tons of carbon dioxide. If you remember from the slide on the emissions, carbon dioxide emissions in 2024 were just under 38 billion tons. So there are only a few years until we're at this 1.5 threshold. If we wanted to limit warming to 2 Celsius, the total budget increases to approximately 3,540 billion tons of carbon dioxide. And at current rates of emission, we would have just a couple of decades until we are committed, with at least a 66% probability, to that level. Living within these forever budgets, the approximately 2,800 billion tons for 1.5 or 3,550 billion tons for 2 gives us a clear marching orders for what needs to be accomplished if we want to strive to hit either of these targets. What I'll argue for the rest of this presentation is that 1.5 is essentially impossible. This 2-degree target, I think, is at the bottom range of what's possible, but there are very compelling reasons to be as close to 2 degrees Celsius above pre-industrial as possible. It's also very important and very compelling to recognize that most of the solutions we need are already here. They're available, they're affordable, they're safe, and they're reliable. I'm going to start out with an image for the cost of electricity from renewables, with solar photovoltaic on the left and wind energy on the right. In this image, you can see the levelized cost of electricity from fossil fuels in the light blue band that goes across both images. It ranges from about $50 to $180 per megawatt hour. And in the period from 2010 to 2019, you can see in the yellow line that the levelized cost of electricity from solar photovoltaics has dropped from almost $400 per megawatt hour to less than 100, so that electricity from photovoltaics is now at the very low end of the cost of electricity from fossil sources. If we look at wind energy on the right-hand panel, you'll see that both onshore in the gray line and onshore in the red line and offshore in the gray line have been decreasing rapidly in cost, and that the levelized cost of electricity from onshore wind, the red line, is now at the very lowest end of the cost of electricity from fossil sources. For new generation, almost everywhere in the world, electricity from renewables is the cheapest source, cheaper than any electricity from new fossil. But there are also several pieces of bad news. I want to start with three. And I think of each of these as being a real kick in the shins. As Adlai Stevenson said, they hurt too much to laugh, but we're too old to cry. First of all, they're costly impacts that increase rapidly with temperature. We're already seeing impacts, and we know that further warming will cause a rapid increase in further impacts. Second, we also know a lot about how fast progress needs to occur for us to limit warming to 1.5, well below 2, as the Paris Agreement argues, 2 or a higher target, and we're way too slow even for the 2-degree threshold. Third, we are, especially in the United States, in an era of strong political headwinds, and we risk not only slowing progress in our country, but removing the potential for leadership on what's clearly the defining environmental challenge of our century. Let's look first at this issue of the way impacts change with temperature. The Intergovernmental Panel on Climate Change, the world's premier climate assessment organization, has found it useful to lump the impacts of a changing climate into 5 reasons for concern. Threats to unique and threatened systems, rare species, important heritage sites, unique one-offs. Reason for concern 2 is extreme weather events, the kind of things we've seen play out in the devastating floods in Texas or the wildfires in Los Angeles this year. Reason for concern 3 is distribution of impacts, the way that climate change has an insidious ability to have the greatest impacts on the most vulnerable communities, often the communities that contributed least to climate change. Reason for concern 4 is global aggregate impacts, things like total impacts on GDP or overall freshwater availability, number of species. And RFC 5 is large-scale singular events, the risk of massive tipping points like a loss of sea ice that leads to a many meters increase in sea level, or thawing of permanently frozen soils at high latitude that leads to a very large release of greenhouse gases that warms the planet independent of what we do with human-caused emissions. Across each of these reasons for concern, you can see that the risk level goes from moderate all the way to very high. The way I think about these levels of risk is that at moderate, yellow risk, we're pretty sure that we can adapt, and that adaptation, the addressing of harms through changes we make in society, can be almost complete. In the red, we understand there to be good aspects for adaptation, but the adaptation will likely be incomplete. And in the purple, the very high risk, we have a solid evidence that we cannot adapt completely and that there'll be persistent harms across society. If you look at what we understand currently at 1.5, we've already seen high and irreversible impacts to unique and threatened systems, and high and irreversible changes in extreme events, and we're in the moderate category for the other impacts. And that's the primary motivation for this 1.5 threshold. That's the aspirational threshold in the Paris Agreement. And you can see that it keeps most systems relatively safe, acknowledging that there are profound impacts in others. At 2C, we're already in the purple, the very high risk, full adaptation, unlikely zone for unique and threatened systems and extreme weather events. And we're grading into the red, the incomplete adaptation in the other three: distribution, global aggregate, and risk of tipping points. By the time we get to 2.5, we're solidly in the purple for unique and threatened systems, extreme weather events, and solidly in the red for all the others. I think it's clear that if we want to lay the foundations for a sustainable future, 2.5 is too warm, and that any kind of a reasonable risk management strategy says we need to limit warming to as close to 2C as possible, and recognizes that the UNFCCC, the Framework Convention on Climate Change, in its Paris Agreement, had a very strong motivation for the 1.5 Celsius aspirational target. If we look at progress to date, it's clear that the progress has been frustrating. This is a figure from the UN Environment Programme's Emissions Gap Report. And what you can see across in the bottom line, the green range, is that the emissions that are consistent with the 1.5 target from 2015 to 2035. In the blue, the emissions that are consistent with stabilizing warming at 2C above pre-industrial. And at the top, you can see what we're actually doing in the black and what we have committed to do in the gray, orange, and red through the Paris Agreement process with nationally determined contributions. And these lead to a huge gap. The gap is really big in 2030, and it's even bigger for 2035. So in the orange line shows what we can count on with commitments that have already been made and are unconditional, in the sense that governments have agreed to do these regardless of or not of whether there's foreign assistance, the kind of environment politically that we're in now. And the red bars show the gap for the conditional NDCs. It's slightly smaller as a result of offers of foreign assistance that have been made but not delivered. And what you can see is that in every case, by 2030, if we want to be anywhere close to either the 1.5 or the 2C range, we would have to be squarely and solidly in an era of rapidly decreasing emissions, starkly different from the pattern that we've seen historically into now, which is continuing increases in emissions. Now, even though this is bad news, and it does indicate that we're addressing the problem much too slowly, it's not the case that emissions are increasing in every country. Here's the pattern of country-by-country changes from 2022 to 2024, and you can see that from 2022 to 2023, China increased emissions dramatically. The US and the European Union decreased their emissions substantially. India increased, international aviation increased, and others increased. From 2023 to 2024, the only region to have a substantial decrease was the European Union. The United States had a tiny decrease, and there was a huge increase in emissions from the countries that aren't called out specifically. By now, we have a couple of decades of experience with gradually decreasing emissions in the USA and the European Union, showing that emissions decreases are possible, but we're not seeing anything like the level of commitment that's essential for delivering on anything like the trajectory that's necessary for 2C. One piece of good news in this overall bad news story is that many estimates have indicated that emissions may peak in China in 2025. And then a final piece of bad news that's important to acknowledge is that we are in an era of strong political headwinds, especially in the United States. It's important to remember that the United States is now the only nation in the world that's strongly focused on climate denial. And by pulling out of the Paris Agreement, the United States has effectively isolated itself from all the conversations about global responses to this overarching challenge. And we also have seen that the investments in climate solutions that were driven through the Inflation Reduction Act passed in the Biden administration are being pulled back, and that the prospect for continuing progress through technology development, infrastructure, and political progress in the U.S. are really struggling under this pullback of resources. It's also having negative economic impacts around much of the country. Okay, given this background, what makes me say that it's not too late? And I think it's important to recognize that the technology is changing rapidly, and we now mostly have the technology we need to bring emissions to zero. Second, even though we are not seeing the level of government investment that would be appropriate in the United States for a rapid progress to solution, we are seeing finance starting to flow around the world. And in some sense, we're close to the point at which there's enough money going into energy technologies so that if it were redirected, we could actually be seeing meaningful solutions. A third is that we are beginning to see real investments in adapting, changing society in response to the impacts that can't be avoided, so that harm to ecosystems and individuals is less than it would otherwise be. And then finally, it's important to recognize that we may have access to some novel kinds of insurance policies that help us cope as effectively as possible in a climate that has already warmed too much for the other strategies to work. Let me say just a few more words about each of these observations. First, when we think about decarbonizing society, eliminating greenhouse gases, the pathway is simple, at least in concept. We need to drastically reduce emissions from electricity and electrify as much as possible. That means we need to electrify transport, electric vehicles, manufacturing, things like electric arc furnaces for steel manufacturing, heating and cooling with heat pumps. Some of these technologies are mature, some aren't. We need to use technologies to remove and store excess greenhouse gases. There are already too many greenhouse gases in the atmosphere, and we have technologies for removing them from the atmosphere into long-term storage under the ground or in forests. And we need to stop contributing greenhouse gases to the atmosphere from deforestation, which still accounts for something like 10% of total anthropogenic emissions. We need to stop releasing methane, a powerful greenhouse gas, to the atmosphere, much of which is coming from oil and gas production simply as a result of industrial sloppiness. And we need to fix food. Food is a source of nearly 25% of our total greenhouse gas emissions. And there are a lot we can do to tighten up the processes that are resulting in these greenhouse gas emissions. If we look at the technology, it's striking how much, for example, electric vehicles have changed in just the last few years, so that in many cases now, electric vehicles are price competitive, especially the electric vehicles from China, with gasoline-powered vehicles, and they're superior in performance, reliability, and attractiveness. If we look at finance, it's clear that there's a big finance gap. Most of the estimates are that we need at the global scale something between $1 and $1.5 trillion a year of investment in alternative energy, in decarbonization. And you can see with the yellow dots in this figure from the Intergovernmental Panel on Climate Change that there are meaningful investments in solar, wind, technology development, nuclear, and hydro, but they don't come close to amounting to the $1.3 billion that's needed. The blue, green, and purple bars indicate the amount of investment that's needed today to be on a path consistent with 1.5 without overshoot, with overshoot, or to limit warming to 2. And you can see that in every case, the investments to date, the yellow ones, are less than the investments that are required, except in the rightmost 2 categories, which is investments in fossil fuel processing and investments in fossil fuel extraction. In extraction in particular, we're investing at the yellow dot much, much more than is consistent with any of the pathways. And while this is a bad news story in terms of where the investments are going, one striking feature of this analysis is that if you were to take the excess investment in fossil fuel extraction and distribute that over the renewable non-emitting technologies, it would be most of the way toward the investments that are required. It's also important to note that we are making real progress with adaptation, whether that's in infrastructure or in social capital or in understanding how to take better care of agriculture and ecosystems, how to provide insurance in a more consistent and reliable way in an era of climate extremes, recognize that many of the most serious extreme events we see tend to be cascading, where one failure leads to another, or compound, where multiple bad things happen at once. And we're even beginning to think proactively about how to move communities out of harm's way in a way that not only addresses the climate challenge, but helps build better lives. And then the final set of things that we can increasingly at least think about deploying are Plan B, pull the ripcord on the safety measures type of responses. And there are 2 big categories of these. They're often called geoengineering. On the left, you can see a number of options for removing greenhouse gases from the atmosphere through processes that range from planting and growing new forests to capturing carbon dioxide with industrial processes and pumping it into the ocean or accelerating the process of rock formation. We know that all these greenhouse gas removal processes work. They're slow and expensive, but they're things we know we could invest in. On the right-hand panel, you can see the concept of solar geoengineering, the idea that we might release another pollutant. People talk often about sulfur dioxide into the upper parts of the atmosphere, the stratosphere, to reflect sunlight away from Earth. And we have high confidence from past volcanic eruptions that this is a viable pathway for decreasing temperature, but we have far too incomplete information as of yet to know whether there are other unacceptable consequences of solar geoengineering. And the priority on understanding more about whether or not solar geoengineering should be a part of our response portfolio is getting to be more and more pressing, is something we really need to do. But it's also important to recognize that we're in an incredibly challenging political environment. Politics, disinformation, incumbent interests from oil and gas producers or from regions that are dependent on income from fossil fuel extraction are really very, very effective in keeping progress slow. We face a deep challenge with short-termism, where we're talking about addressing needs that need to be addressed over the next several decades in an environment where many CEOs are thinking about next quarter and not the next decade. It's important to recognize that many nations face profound burdens from transitioning away from fossil fuels. Something like 30 countries around the world get the majority of their national income from extraction taxes. In some cases, we're making the investments we need to see, but many we're not, and especially the pullback from investments in science in the United States is going to make it much harder for the world to have the technologies it needs, and certainly for the U.S. to have the leadership it needs. And there are some important areas where the technology simply isn't mature yet. And that includes technologies for example, zero emissions aviation, zero emissions manufacturing, or for very long-term storage of electricity. So currently, where does that leave us? We're on a path to warm to approximately 2.5 to 3 Celsius with agreements and commitments that are already in place. I would argue that that is way too much and that we do need to accelerate ambitions dramatically. But it's worth noting that when I started my career, we were looking at a business as usual outcome of warming of 4 to 5 degrees Celsius, and that no longer seems like the most likely probability, partly because of the dramatic success of renewables and moving away from coal especially. We're already brushing up against the 1.5 Celsius aspirational target in the Paris Agreement. It's important to recognize that that's essentially impossible. And the nominal goal of the Paris Agreement, limiting warming to well below 2 degrees Celsius, would be exceptionally challenging and I think is unlikely to occur. But if I look at where we are in terms of commitments from countries, companies, states, cities, individuals, and I look at the technology and the costs, it seems to me that something close to 2 degrees Celsius above pre-industrial is still very, very ambitious and far from being a done deal. But it's not unrealistic, and that's where we should be headed. And when I think about it, what I feel is that we are in a world of rapidly increasing impacts, rapidly increasing awareness of the fact that there are things we need to do. And with the exception of the United States, a world where more and more of the countries are on board, committed to action, and striving to deliver solutions that will relieve us from the most severe impacts of climate change. And I close with a profound sense of optimism that this is something we can accomplish, but we need to make it a much stronger, sharper, more important focus.